At this very moment, you are being touched by ghosts. But these are not the spirits of folklore. They are something far more ancient and profound. They are photons, tiny particles of light that have journeyed across the vast, dark emptiness of space for millions of years, sometimes billions of years. It tells us that the universe is not something that is simply, out there, separate from us. It is a story that is constantly unfolding, and the light reaching us today is the latest chapter to arrive. The sun's light, for instance, takes about 8 minutes to cross the 93 million miles to Earth. This means that if the sun were to suddenly vanish, we would remain blissfully unaware for a full 8 minutes, basking in the glow of a star that no longer exists. This temporal lag is a fundamental property of our universe, and it is the key that unlocks our ability to study its origins and evolution in a direct and tangible way. When we extend this concept to the stars, the timeline stretches dramatically. The nearest star to our solar system, Proxima Centauri, is a little over 4 light-years away. The light we see from it tonight began its journey around the time today's college freshmen were being born. When we gaze upon the Andromeda Galaxy, the closest major galaxy to our own, we are seeing it as it was 2.5 million years ago. That light started its journey long before modern humans walked the Earth. The photons striking your retina carry information from an era when our distant ancestors were just beginning to shape stone tools. The sky, therefore, is a magnificent time machine, available to anyone with the curiosity to look up. This journey into deep time does not require complex equations or a sophisticated laboratory. It only requires a clear night and a moment of quiet contemplation. By simply looking at the stars, you are engaging in the act of observational cosmology. You are connecting with the universe on the most fundamental level, receiving messages that have been in transit for eons. This perspective can infuse the night with a profound sense of calm and wonder. It reminds us that we are part of a continuum, a grand narrative that began long before us and will continue long after we are gone. The silent, twinkling sky is not so silent after all. It is whispering the epic story of everything. When we look at breathtaking images from telescopes like Hubble or the James Webb Space Telescope, our senses are overwhelmed by the sheer density of cosmic objects. This visual richness, however, creates a profound illusion. The truth is that the universe is defined more by its emptiness than by its contents. The distances between stars within a galaxy and between the galaxies themselves are so incomprehensibly vast that if you were to travel through space, your dominant experience would be one of overwhelming, near-perfect emptiness. It is a silent, dark void, punctuated only by the rarest islands of matter. Yet, the story of what fills this void becomes even more mysterious and compelling. The matter we can see, stars, planets, gas, dust, accounts for less than 5% of the total mass and energy in the universe. This is a shocking and deeply humbling revelation for science. It means that all of human history, all our art, all our discoveries, all the familiar material of our world, are built from a tiny fraction of what is actually out there. The vast majority of the cosmos, about 95% of it, is composed of two enigmatic substances that we have named but do not understand. Dark matter, dark energy. Dark matter makes up about 27% of the universe. We infer it from its gravity, an invisible scaffold holding galaxies together. Black holes have captured the public imagination as the ultimate cosmic monsters. Voracious whirlpools of gravity so intense that nothing, not even light, can escape. A black hole is the collapsed core of a very massive star, surrounded by an event horizon, the one-way door of the observable universe. The laws of physics as we know them break down. Space and time are warped to an extreme degree. Yet the regions around black holes are among the brightest and most energetic places in the universe. Infalling matter does not plunge straight in. It spirals, heating to millions of degrees. The disk blazes across the electromagnetic spectrum. around supermassive black holes. These disks can power quasars that outshine all the stars of their host galaxies combined. Not all matter is swallowed. Powerful magnetic fields can redirect it into colossal jets near light speed. These jets plow through galaxies, clearing gas and regulating star formation. Black holes, ultimate agents of collapse, also sculpt cosmic creation, shaping the galaxies they inhabit. The act of devouring matter becomes a lighthouse, announcing their presence across billions of light years. Our cosmos is mostly empty, and what isn't empty is mostly unknown. For nearly all of human history, our catalog of known planets was limited to those within our own solar system. We knew rocky worlds like Mercury and Mars, gas giants like Jupiter and Saturn, and our own unique, water-rich Earth. But in the last 3 decades, that picture has been completely revolutionized. New techniques triggered a golden age of discovery. Thousands of exoplanets, a veritable menagerie of worlds that challenge our imagination. Hot Jupiters, massive gas giants with years lasting mere days, atmospheres scorched to thousands of degrees. Super-Earths, rocky and larger than Earth, some with thick skies or deep global oceans. Worlds orbiting 2 suns, where double sunsets paint the horizon. Most tantalizing are Earth-sized worlds in the habitable zone, like those of TRAPPIST-1, where liquid water might persist. We haven't found life yet, but finding potential water is a monumental first step. With hundreds of billions of stars, on average at least 1 planet per star, our galaxy alone hosts hundreds of billions of worlds. The light our eyes see, red to violet, is only a sliver of the universe's spectrum. The cosmos broadcasts in radio, microwaves, X-rays, gamma rays, and new telescopes gave us new senses. A hidden universe appeared, dynamic, violent, spectacular. Radio waves pierce dust, map cold hydrogen, the raw material for stars, and reveal the faint afterglow of the Big Bang, the CMB. A baby picture of the universe with clues to its origin, age, and composition. High-energy light exposes extremes, shock waves, jets, and matter near light speed. Our atmosphere blocks much of this, so we place our eyes in space. The same galaxy looks different in each band. Serene in visible, warm in infrared, raging in X-rays. Each wavelength carries a different message. To understand the universe, we must listen to all its voices. The secrets of the cosmos are hidden by distance and by light itself, waiting for the new eyes we build. A cosmos of constant creation and destruction, written in light. The universe is not a static stage. It is an active participant in its own story. A story that began 13.8 billion years ago, starting with the Big Bang. Not an explosion in space, but an explosion of space itself, ever expanding and cooling. Expansion enabled gravity to pull matter together, building stars, galaxies, and the vast web. Our place is recent and profound. On a 1-year cosmic calendar, the Milky Way in May, Earth in early September, and all recorded human history in the last 14 seconds. We are latecomers, yet the universe's first known attempt to understand itself. One of today's great puzzles, cosmic expansion, is accelerating. The likely fate is a big freeze, light stretched away, galaxies too distant to see. Bleak as it sounds, it grants our era special significance. We live in a cosmic springtime, rich with light and information. We can piece together the story from beginning to possible end. The universe has a story, and we are fortunate to be here to read its pages.